Hi, today we are going to learn about the properties of ratios of areas of triangles. And one second. Okay, property one. Property one essentially says the ratios of areas of two triangles is the same as the ratio of the product of their bases. Okay, what does that mean? Here, let's look at these two triangles, ABC and triangle PQR. You know that the area of ABC is calculated as half of base into height. Here the base is BC and the height is AE, because AE is a line which is drawn from the vertex that is opposite the base at 90 degrees. Okay, this is 90 degrees. So the area of ABC is half times half of half multiplied by BC multiplied by AE. Similarly, triangle PQR, this is the line that is perpendicular to the base from this vertex, and here it forms 90 degrees. So the height is actually PT. Okay, the height is PT and the base is QR. So area of PQR is QR multiplied by PT. Therefore, the area of ABC divided by the area of PQR is equal to, we just substitute these values, half of BC into AE divided by PQR, that is half of QR into PT. Half and the half will go away, and then you will be left with BC multiplied by AE divided by QR multiplied by PT. So BC is nothing but base of ABC and AE is the height of ABC, and here QR is the base of PQR and the height is PT is the height of PQR. So this is what it says here. The areas of the products, areas of the ratio of areas of two triangles is the ratio of product of the bases and the heights, which is what we found here. That's property number one. Let's go to the second property. Second property, oh, I'm sorry, we'll just do an example of property one. Here, in this figure, you have two triangles. One is ABC and the other is PQR, and the height and the bases are given. So now we just want to calculate the ratio. So here it's a pretty simple problem. So you have the height of AE, which is height of ABC, which is AE, is 15, and the base is 20. So we calculate the area of ABC as half into the base of ABC, which is 20, multiplied by 15, which is the height of ABC. Similarly, triangle PQR, you have half multiplied by 10, which is the base, that is QR of this triangle PQR, and multiplied by 14, which is the height. So that becomes, so when this becomes 20, so remove half and half, so 20 multiplied by 15 divided by 10 multiplied. So you get 10, and this becomes 2, 20 by 10 becomes 2, and then 2 you can cancel off 14 as 7, so then you get 15 by 7. So the ratio of triangle ABC to the area of triangle ABC to the area of triangle PQR is 15 by 7. So that's the ratio. Okay. Next, go to property 2. For property 2, the triangles which the common base, the ratio for triangles which have a common base, the ratio of the areas of the two triangles is the same as the ratio of the corresponding heights. We will see how that happens. Here, take these two triangles in this figure, ABC and triangle PBC. Both have the same base, BC, right? And you see H1 is the height of ABC, which is AE, and PC is perpendicular to CB, which means that PC is the height. PC is the height H2 of the triangle PBC. So again, we have the area of ABC as half of BC into AE, and area of PBC is equal to half of BC into PC. So the area of ABC will now be equal to half of BC into AE divided by this. And here then half BC and half BC cancel out. So you are left with AE over BC. And as we have seen, AE is nothing but the height H1, and PC is nothing but the height H2 of the second triangle, which both of them have a common base. Hence the area of triangle 1 over area of triangle 2 is equal to the height 1 or height 2, the corresponding heights. So if you have a common base, then the ratio is the same as the corresponding heights. Okay, that's pretty simple. Let's go to the next one. Property number 3 says for triangles with the same height, the ratio of the areas of two triangles is the ratio of their corresponding bases. So it's exactly the opposite of property number 2, where they say if we have the same base, then the ratio is the ratio of their corresponding heights. Here, if it's the same height, it's the ratio is the ratio of their corresponding bases. Here is how we see. There are two triangles here again, ABC, triangle ABC, and then you have triangle APQ. What happens here is both have the same height, right, and AE, and that's H1. So we have to prove here that the ratio of the bases is the same as the ratio of the area of a triangle. Again, use the same formula. Area of ABC is half of BC into half of AE, which is the same as the first two properties. Area of APQ is equal to half of PQ, which is the base of APQ, and the height is AE. Here again, half will cancel out, and AE and AE will cancel out. So what you're left with is BC over PQ, and BC is nothing but the base of ABC, and PQ is nothing but the base of APQ. So the area of ABC over area of APQ is the same as B1 over B2. So property 2 and 3 are kind of similar. If you have common bases, then the ratio is the same as the heights, and if you have common heights, the ratio of areas common is the same as that of the corresponding bases. Next, property number 4. For triangles with the same height and bases, the ratio of the area of two triangles is 1. Or it also means that they have the same area. Let's see how that happens. Here there are two triangles. These are two triangles A, B, C, and the other triangle is P, B, C. Here you see that these two have the same base, which is BC, right? They have the same base, and the heights of these two are the same. Here we have that MP, this line MP is parallel to BD, and we know that if there are two triangles which lie exactly between two parallel lines have the same height. So here in this case H1 is equal to H2. Okay, so since MP is parallel to BD, the heights of these two triangles are the same, and we also see here that the base of the two triangles are the same, which is BC. So again we apply the same formula. Area of ABC is again our familiar half of BC into AE, and area of PBC is half of BC into BD. BC again because the base of PBC is BC and the height is BD. That is equal to, so here again these halves cancel out, this and this half cancels out, and then BC and BC cancels. So we are left with AE over PD, which is nothing but H1 over H2. But since the line MP is parallel to BD, the heights are the same. So H1 is equal to H2. So that is almost equal to 1. So it's like H1 over H1 or H2 over H2. So that means the area of ABC divided by the area of PBC is nothing but 1, which means that the area of both the triangles are the same. So this is the fourth property. If you have a common base and a common height, or the same height and the same base, then the ratios of the two triangles are the same, which is pretty obvious in this example. Let us summarize again. Ratio. The first property was the ratio of two triangles is the ratio of the product bases. So here you see A1 over A2 is equal to base 1 into H1 over base 2 into H2. Second was, if you have a common base, the ratios are the same as the ratio of the heights. Third one is, if you have a common height, if you have the same height, then the ratio of triangle is the same as the ratio of the bases. And if you have the same height and the same base, the ratio of the two triangles is 1. So A1 over to A2 is 1, or A1 is equal to A2. Okay? These are the four properties that you need to remember.